if a circuit has two or more independent sources, one way to determine the value of specific variable, that is voltage or current, is to use the nodal or mesh analysis. Another way to determine that contribution of each independent source to the variable, that approach is known as superposition theorem. Now, if we determine that contribution of each independent source, after that if we add them up, then that theorem is called the superposition theorem. Now, this idea of superposition reset on the linearity properties. Now, what are the statement of the superposition theorem? In the superposition theorem, that principle state that the voltage across or current through an element in a linear network circuit is the algebraic sum of the voltage across or current through the element due to each independent source acting alone. So these are the superposition theorem. Now we are using few steps to simplify that circuit using superposition theorem. So what are the first steps? First steps, turn off all independent sources except one sources. Suppose if the circuit is there two or more than two sources is there, we keep one sources on and off other two sources. Find the output voltage or current due to their active sources and the repeat source for each independent sources. Now I will discuss with few problem, then it will be more clear what are the superposition theorem. Now if we draw the one circuit in the superposition theorem, there the two or more circuits are there, then we can solve that equations using superposition theorem. Now I draw one circuit where two sources are there. In these examples, I keep the sources, two sources, and few resistance we connected here. Now we are use that one sources, that is 50 voltage, and another sources we keep, that is 20. Now we are use the three resistance. So these are the 10 ohm, this one 20 ohm, and this one 20 ohm. These three resistance are connected in these circuits. Now what are the first steps? The first steps we check how many sources are there. So here two sources are there, then we can solve this problem using 2 plus 1, that is 3 steps. So first case, we have to off one sources and on another sources. Let me stop the one sources, that is 20 voltage. Now 20 voltage is voltage sources. So if we draw the circuit after off this 20 voltage, the circuit looks like a now we off the 20 voltage sources. Now circuit is looks like, and this is 15 voltage, 50 voltage as it is. Now you have to remember, whenever we off that voltage sources off, then circuit act as a short circuit. If we off the current sources, then the circuit act as a open circuit. So here we off the 20 voltage, that is the voltage source. So that circuit is act as a short circuit. Now if we simplify this circuit again, then here 50 voltage is remaining same, and here 20 and these two are in parallel. So we can write here 10 and the 20 and this 20 we can use using parallel. So now we just change this voltage for better understanding. It is 30 voltage. Now 20 and 30, if it is parallel, then 20 into 30 divided by 20 plus 30, that will equal to 12 volt, 12 ohm. So here 12 ohm, here 10 ohm is remaining same, and here 15 voltage is remaining same. Next again we can solve these equations. Now 10 and 12, that is in series connections. Now the what are the circuit? The circuit is So what the total resistance? Total resistance is 22 ohms and here 50 voltage. Now these are the final circuit. So from this circuit, we can find out the total current easily. So what are the total current? In total current, if we consider that is IT, I capital T, that will equal to that VT total voltage divided by total resistance in this circuit. So that will equal to 50 by 20. That's mean 2.27 amperes. So now once we calculate the total current, then we can calculate how much current will be flow in this resistance, 30 ohm resistance. Now in the superposition theorem, we have to calculate that current through particular resistance. Suppose in these questions, we have to calculate, find the current to 30 ohm resistance. So we want to calculate how much current will flow through this 30 ohm resistance, that we have to calculate. Now as per questions, if we want to calculate the current which run through the 30 ohm resistance, so that current we can consider suppose I1. So now I1, that will equal to the total current, that IT, into that which current we want to calculate, in that current running through the 30 ohm resistance. So that opposite branch resistance divided by opposite branch resistance plus current branch resistance. So this is the rules for current divisions rule. So current divisions rule say that total current, that will equal to total current divisions rules, that I total current into resistance of opposite branch divided by resistance of opposite branch plus resistance of running branch. So running branch means we have to calculate that I1 through the 30 ohm resistance. That's why it is 30, and opposite branch resistance value is 20. That's why you write here 20 and 20. And total current we already find out here 2.27. So now we calculate that I1, that will equal to 2.27 into 20 by 50. So we keep that is suppose X, that value is X. After calculations, suppose we are finding this value is X. Let's start with that another steps. This is the steps 1. Next steps, in the step 2, we off that another sources. So first we off the 20 voltage sources. Now we can off the 50 voltage sources. Now if we off the 50 voltage sources, what are the circuits? The circuit, it is off means it is short circuit. So again we can write here, it is 10, 30, 20, the 20 voltage and this one. Now here 50 voltage is turned off, that is act as a short circuit. Now 10, 30 and 20. Now we have to calculate the current here through the 30 of resistance. Now let's see, we use that current, suppose I2. Now for here we simplify this circuit again. If we simplify this one, now you see the supply is that way. So current should be follow this way. So the 10 ohm and 30 ohm is the parallel connections. So we simplify these equations. Simplify this circuit. After simplifying 10 and 30 in a parallel, that value is 10 into 30 divided by 10 plus 30, that will equal to 7.5. So here we write the 7.5 and here 10 as it is and 20 voltage. Now again we simplify this circuit. Now 7.5 and 10, that is in series connections. So we can write this circuit 10 plus 7.5, that is, sorry, these are the 20 voltage. So these are the 20. So 20 plus 7.5, that is 27.5 ohm, and this is 20 voltage. Okay. So from here, we can find out the total current. If we find the total current, IT, again, whenever the source is 20 voltage, that will equal to here 20 divided by 27.5. So let's see, that is 0.727 ampere. Now we have to calculate the how much current will flow through this 30 ohm resistance. So here we consider the current is I2 whenever the source voltage is 20. So now I2, that will equal to total current IT into opposite branch resistance. What are the opposite branch resistance? Now the opposite branch resistance is 10. So we write here 10 divided by opposite branch resistance 10 plus 30. Now here current is flowing that direction. That's why we keep 10 is the opposite branch resistance and 30 is the current branch resistance. So now this value, suppose Y. Now you see this current direction is downwards. In the previous cases, the current direction also downwards. If the both directions is same, then we can find the total current that will flow through this 30 ohm resistance whenever two supply voltage is there. So what are the total currents? So I draw the final circuit where 50 voltage and 20 voltage are connected here. Here 20, 30 and 10. Now how much current will flow through this 30 ohm resistance? That total I, that will equal to that I1 plus I2. That's mean X plus Y. So here the plus sign, that's why, because the current direction for both steps it is same. That's why it is plus. If the current direction is different during the calculation time, then we keep the minus. Let's start with another example where two different sources are there. First example, we are using that same volt source, that is voltage source. Now we are dealing with that another circuit where different sources are there. Now let's see the one circuit diagram where one current source and one voltage source we apply. And here parallel with current we are using that one resistance 5 ohm, here 20 ohm, here 10 and here plus minus 30 voltage. Now as per the superposition rules, we have to off one sources and on another sources. So first we off the 30 voltage sources. Now if we off the 30 voltage sources for the steps 1, then the circuit acts as a short circuit. So we draw the circuit again. The circuit acts as a short circuit and other resistance as it is. So here 20, here 5 ohm and here the current is 2 ampere. Now in these circuits, what are the direction of the current? This way and this way. Now in these questions, we have to find out the total current through 20 ohm resistance. So what are the questions? Find the current I through 20 ohm resistance. That is our question. So we have to find out the current through 20 ohm resistance. Now here we first off the voltage sources. That's why it is short circuit. Now the circuit is looks like. Now here we can easily find out the total current through this 20 ohm. So total current here is 2 ampere. So we directly write the total current, that is IT, whenever the 52 ohm supply voltage is there, that is 2A. Next, we have to find out the current through this 20 ohm resistance. So now we are considering that current is I1. So what is the I1? I1 that will equal to, what are the rules? Total current, that is IT, into opposite branch resistance. So opposite branch resistance is 5 divided by opposite branch resistance 5 plus current branch resistance 20. So that value is 2A into 5 plus 5 plus 20, that one. Sorry, we are missing our one resistance here. In this circuit, we miss one resistance. So we have to dot resistance again. Suppose this is 10. So here 10 plus 20, again we have to write. So now what are the value? The value is 0.28 and the directions is this way. Now you must remember the directions. You can see the direction is right hand side. Now we find for the 12 ampere current, the current is 20.28 ampere. Okay, or we can consider this is suppose X. Next, for the step 2, we off the current sources and on the voltage sources. Now if we off the current sources, the circuit is act as a open circuit. If circuit is act as a open circuit, then the circuit is These are the supply voltage. Now here we are keep the supply voltage 30, and this is 5 ohm, this is 20, and this one 10. Now we have to find the current through the 20 ohm resistance. Now we consider this current is I2. Now here it is open circuits. That's mean the equivalent circuit means simplified circuit is, it is open circuit. That's mean we can directly write 20, 10 supply voltage, and these are the circuit. So now here 30 voltage, here 10, 20, and 5 ohm. Again we simplify that circuit, then it is, you can see here 5, 20, and 10 all are in series connections. So we can write total resistance, that is 35, and the voltage is 30. So now from here we can find the total current IT, that will equal to 30 voltage divided by 30 ohm. That's mean it is 0.85 ampere. Now we have to find the current flowing through the 20 ohm resistance. So what are the current we consider? It is I2. So I2, that will equal to total current IT into that opposite branch currents. So in the opposite branch current is 5 divided by opposite branch current plus running branch current is 20 plus 10. So here IT equal to 0.85 into 5 by 35. So suppose this value is Y. Now the direction of the Y also in this way. So what are the total current whenever we are designing the circuit? The total current, whenever the main circuit is there, total current we can write here whenever the two supply 30 and the another current, the 2 ampere is present, then the value is 5, 10, 20. The value I to this 20 ohm resistance, that will equal to I1 plus I2, that will equal to X plus Y. These are the answers. So using this formula, we can calculate the superposition theorem. Now we solve that another problem in superposition theorem where two different resistance are there. Now I draw the one circuit here. One is the 20 ampere current, another is the 20 voltage is the supply voltage. Now we have to find the current through the 4 ampere 4 ohm resistance. So we have to calculate this 4 ohm resistance. Now first we consider the 20 ampere current is present and of the 20 voltage. Now what are the circuit? If we keep the 20, now these are the 20. Now if we off that 20 voltage, the circuit act as a short circuit. Now if circuit act as a short circuit, these are the 20, this is 4, this is 10, and this one is the 20 ampere current. Now you see here, you have to remember whenever the circuit we are off this 20 voltage, now this circuit is a dummy resistance. Why? Because after 4 ohm all current pass through the short circuit. No current flow through the 20 ohm resistance. So that's why this network we consider as a dummy network. So now what are the circuits? The circuit, again we can read out this circuit. There is a 20 ampere current, here 4, and here 10, and if it is dummy network, then we consider it is single line. So it is 10, 4, and it is 20. Now we have to calculate the current through this 4 ohm resistance. So we consider it is I1 now. Now the total current here, what are the total current? Total current is given, that is IT equal to 20 ampere. Now we have to calculate the I1 equal to total current IT into opposite branch resistance here 10 divided by opposite branch resistance 10 plus current branch resistance. So that is equal to IT that will 20 into 10 by 14, that will equal to 14.2 amperes. Now you can see the direction of the current is this way. Now next, for the step 2, we turn off that 20 ampere current and off the 20 voltage. Now what are the step 2 circuit? If we off the 20 ampere current, the circuit is act as a open circuit. Now these are the voltage, and this is 10, 4, 20, and this voltage is 20. Now you see supply voltage is this way. Now the current direction is this that way, and another current is this one. So we consider this current through this 4 ohm resistance is I2. Previous case we considered I1, now we consider it is I2. Now again we simplify this circuit. You can see here it is short circuit. Short circuit means that 10 and the 4 ohm we can calculate as a series connections. So that 10 and 4, that is 14 ohm resistance, that 14 ohm resistance series with the 20 ohm resistance. So directly we can write 14 into 20 divided by 14 plus 20, that will equal to 8.23. So if we simplify this circuit again, so here only one resistance, that is 8.23, and supply that 20, 8.23 ohm. So from here we can find that the total current here IT, that will equal to total current, that will equal to 20 divided by 8.23. Okay, so suppose this one is 8. How much this one? Suppose this value is, we consider the A. Now we have to calculate the current which is flow through this 4 ohm resistance. So that is, we consider I2. So I2, that will equal to total current IT into that opposite branch resistance. Here the opposite branch resistance is which one? The opposite branch resistance. Opposite branch resistance is in this circuit. Here the opposite branch resistance is 20 divided by opposite branch resistance plus that current to resistance, 10 plus 4. So from here we can calculate, suppose this value is Y. So now previous cases we consider I1, that is 14.2, we can consider suppose X, and direction is the right hand side. Here you can see the direction is the left hand side. Now if the direction is opposite, so total current that will flow through this 4 ohm resistance, that will equal to that previous current, that is X minus of current. So this is minus, why? The direction is opposite. Okay, so like that we can solve any superposition theorem.